So second phase, so at this point, I've created just to review, I've created my first layer model where I used a gradient boosted tree regression on weekly aggregated data, and it was pretty good performing. So I'm able to predict average weekly resting heart rate fairly well with this model. So now I took a second phase where I want to look at their best week. So at any point, the week that had the lowest resting heart rate, and I want to compare that with their most recent week to be able to give feedback on the most recent week so they can make any changes for the upcoming week as necessary to help reduce their resting heart rate. So that's what I did with the second phase. Originally, I was going to try to use tree-based algorithms again for this second phase because I used that in the first one, but I kind of ran into a conceptual issue where since I was separating these into 2 week data sets, running tree-based algorithms was probably not going to work because the number of observations was so few. So if I kept it at the weekly level, there was only going to be one observation in each of these kind of weak data sets. Even if I broke it up into daily observations, it would still be at most 7 observations for 19 variables. So I just felt like the decision trees were not going to create, good models for this. So I switched to doing linear models, which there are definitely some drawbacks with that, which I didn't really get into. But I used linear models here because now I was able to work with smaller data sets in a better way. So I had to do a bunch of data wrangling again, because now I'm working with daily data. This involved taking the weekly level data and identifying those weeks and then pulling the daily data from those specific weeks. So there was a lot of data wrangling, which was, I guess, fun to figure out, fun in a strange sense. But I learned a lot. And let's see, I use more time functions to then to pull the data that I wanted, because again, I had to work with ranges. So use more time functions, which were important. So you'll see that in the code if you're interested in that. Now I get into, and I also had to deal with schemas, reformatting my data, and all that. So then I pulled the predictions from that first layer model, and I took the differences between those weekly predictions and each of the daily observations. So I created a column for that, because that's what my second layer of modeling was going to predict. It was how much these weeks differed according to kind of what the overall weekly profile would have predicted. So I added that to my data frames, and then I ran linear regression models trying to predict that from my scaled features. So I did scaling earlier. So scaled features, and performance was really good. Not surprising. It explained everything exactly, which I'm fine with overfitting because I'm again trying to create the best profile for these weeks. I took those results and I did a chart, which I talked about this in my slides, so I'm not going to get into all that. But then I also did a second thing. So here is the predictions of the differences from the weekly aggregate and the daily observations. I took absolute values of the linear models because the sign really didn't matter. I couldn't interpret the sign anymore because it was about change from the aggregate, not in any particular direction. So I couldn't really interpret signs. So I took absolute value. Another note from this is that you can't compare across the different rows because the final 2 columns, the rightmost 2 most columns are based off of linear regression, and then the one in the middle, overall weekly, is based off of the gradient boosted tree. So it's different. You can compare the rightmost columns, the 2 over there, but you can't compare that with the one in the middle. But since I was not really able to interpret the exact nature of these relationships, I did a second set of linear models, but this time I went to predict the actual daily resting heart rate. So not the differences that I did before, but the actual resting heart rates from the variables. And interestingly enough, I got the exact same output, just now I didn't do absolute values anymore. So now you can see the signs, but all the coefficients were the same, which was kind of I was not expecting that. But this now provides more interpretation that I can focus on the exact relationships. So then I did some takeaways from that, and I included that all my slides. But that is my code. So overall, this provided a lot of experience working with an API, messy data, working with HTTP stuff, working with how to pull data from a web API, as well as all the machine learning functions and data wrangling that I needed to do that I showed in the demonstration. So hopefully, if people are interested, you can check out my data or the code. And yeah, thanks a lot.